All right, time to get ready for our semester test. Number one starts off asking for the domain and the range of the following equation. So for this one, you can always put it in the calculator to see what it looks like, but I know it's going to go right 3, up 9, and that's going to make it reflect. So right 3, up 9, and it's going to be facing down. It should look something like that right there. And we can put it in the calculator, it should look something like this as well. But my domain for every quadratic is all real numbers because it goes forever left and forever right. My range goes from bottom to top, and the lowest it goes is negative infinity. The highest it goes, the stopping point right here, was up 9, and it touches that 9. So there's my domain and range. And again, I can always put it in my calculator, negative x minus 3 squared plus 9, and graph it. And there you go, it looks similar to that. All right, number 2, what is the domain range of this function? And so again, I know it's a quadratic, I know it's facing upward because it's not a negative in front. And so we can go to the calculator and find the vertex, or we can find it by hand as well. So my domain will be all real numbers. For my vertex, for the x, I'm going to do negative b over 2a, which is positive 4 over 2 times 2, which is 4 over 4, which is 1. So my x is 1, and then I'll plug in 1 to find my y value. So 2 times 1 squared minus 4 times 1 minus 10. That's going to be 1 times 2 is 2, minus 4 minus 10. That's negative 2 minus 10 is negative 12. And this one is going to be facing upward. So my vertex is at 1, negative 12 down here, and it's going to be facing up. And so my range is going to have a low point of negative 12 and go all the way up to infinity. This one asks, what is the parent function? This function has a starting point and goes up and to the right. That's a square root function. Also looks like y equals square root of x. That's the parent function right there. Number 4, find the vertex. We'll do like we did on number 2. For my x, I'm going to do negative b over 2a, which is going to be negative 14 over 2 times 1, which that's 2. That's going to be negative 7. So negative 7 is my x, and now I'll plug it in to find my y. So negative 7 squared plus 14 times negative 7 plus 57. And so negative 7 squared, I know that's 49. 14 times negative 7 is negative 98 and plus 57. And so 49 minus 98 plus 57 is 8. And I could also put this in the calculators. Y equals x squared plus 14x plus 57 and graph it. And I can see the graph, it's up there. So that glare wasn't very good. I can see the vertex is right there, so I can go to my table and see where does it shift. Or where's the turning points? Right here I can see these numbers are going down, and then all of a sudden at that 8, it starts going up. So there's the turning point right there at negative 7, 8. I can also, in my graph, I can go to the calculate option and calculate that minimum value. So I can go all the way to the left. Right now that's where my x is. The cursor, there it is right there. So I'm going to trap the vertex. I'm going to go to the left bound. I'm going to go to the right bound, trapping that vertex, and press it one more time. Negative 7, 8. That's my vertex. Number 5 says to find the inverse of each of the following. So I'll come out here to the side. We'll switch our x and y. So x equals 4y minus 3. I'll add the 3 over, and I'll divide by 4. And so for this one, y equals 1/4 x plus 3/4. And then I'll do this one. I'll switch the x and y. So x equals y minus 5 over 4. We'll multiply the 4 over to get 4x equals y minus 5. Then we'll add the 5. And so y equals 4x plus 5. Come over here. X equals y plus 11. We'll subtract the 11. And so y equals x minus 11. And then for my last one, x equals y plus 7 over 3. I'll multiply by 3 and then subtract the 7. And so y equals 3x minus 7. All right, this one's a discrete function, so it's not continuous. It doesn't connect these points. So it doesn't include on the domain and range all the numbers in between. It's just going to be listing all the different values. So for my domain, I'll list all my x's. So I've got 1, 2, 3, 4, 5, and 6. For my range, I'll list all my y values. So I'm going to start down here at -1, 0, 1, 2, 3, and we're going to skip up to 6. And there's my domain and range, just listing all those values. What are the factors? So it's not asking me to solve, I'm just going to factor it. I'm going to do that x method where I have a times c on top and b on bottom, and figure out what multiplies to the top and adds to the bottom. So 2 times -9 is -18, 3 is on the bottom. I'm going to try and think what multiplies to -18 and adds to 3. It's going to be 6 and -3. And then we'll divide by the a on bottom, so divide by 2. This simplifies to be 3 over 1. And so the bottom number is attached to your x, and the top goes with it. And so I've got x plus 3 and 2x minus 3. The domain and range of the quadratic function. Again, I could put this in the calculator. This one's missing the b, and so this could be standard form or vertex form. I know it goes up 4. It doesn't go left or right at all, and it's going to reflect, so it's going to go downward, and so it should look something like this right. So I can also put it in the calculator just to see what it looks like. And so in my y equals, I'll put -3x squared plus 4 and graph it. And it looks pretty similar to my graph right there. So again, a quadratic, the domain will always be all real numbers. My range starts at -infinity, goes all the way down to the bottom, and the highest point right there is 4. List all the transformations. So that negative is going to reflect over the x-axis. X plus 2 will go left 2, and -7 goes down 7. All right, so we'll start off by graphing this. So that's going to go right 3 and up 1. There's my vertex. It is going to go up, so we're going to go right 1 and up 1 because 1 squared is 1. We'll go right 2 and up 4 because 2 squared is 4. You could also get these points in the calculator, but there's no equal, so this is going to be a dotted line. So we have a dotted parabola, and then it's greater, so we're going to shade above all these points. So we're going to shade inside on this parabola because inside is above the parabola. And then ask, would 4, 7 be a solution? So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Yes. It lands inside the shaded region, so it is a solution. The theater collected $15 for 375 tickets sold. There's adult tickets and student tickets. Those are my two variables. And so my first one, the number of adult tickets plus the number of student tickets equals 375 tickets total. So no money involved, just number of tickets. Next off, I'm going to have my money involved. So $5 per adult ticket plus $3 for a student ticket gets the total of $14.15. And now we're ready to put it in my matrix. So second matrix, I'm going to go over to edit. This one's just a 2 by 3. 1, 1, 375, 5, 3, 14, 15. And we're going to go to that double REF. And there's my answers. So the adults was first. That's going to be my first answer. Students will be my second. And so 145 adults, 230 students. Then we went to the outlet mall. We've got jeans were on sale for $25 a pair, shirts and hats. She spent a total of $215 and she bought 14 items. She also bought 3 times the number of shirts as she did hats. Write the system. And so it has X will be jeans, Y shirts, Z hats. Just for me, I'm going to keep it J, S, and H just so I know which variable is what. And so I'm going to get this matrix ready. And so the first one, she spent $215, and so that's going to include the money. And so 25J plus 15S plus 10H equals the total 14 items. And then my next one, I'm going to include just items. So J plus S plus H equals 14 items. Oh, sorry, this wasn't 14. This was 215. So that involved the money. I messed that one up, 215. All right, and then my last one says she bought 3 times the number of shirts as she did hats. That means there's more shirts, and so make sure when you write your equation, you should have more shirts. So for every one hat, she bought 3 shirts. That's the way you would do it. So for every hat, you'd multiply by 3 to get the number of shirts. And then to get a matrix ready, I'll just subtract the 3H over. You could have done it the other way and subtracted the S over, but I'm going to have the S minus 3H equals 0. And so now we're matrix ready. Second matrix, this one's a 3 by 4, 25, 15, 10, 2, 15, 1, 1, 1, 14, 0, 1, negative 3, and 0. And so there's my answer. There's 2 jeans, 9 shirts, and 3 hats. And the question asks, so honestly, we didn't even have to solve it. It just wanted us to write the equation. So here's the equations, but if it did want you to solve, 2, 9, and 3 for jeans, shirts, and hats. Solve the following, and so we'll subtract 4 over. 3x minus 8 squared is equal to 9. To get rid of the squared, we'll take the square root of both sides. And anytime I go square to square root, I'm always going to put a plus or minus in front. Because 3 squared is 9, but also negative 3 squared is 9. It could be either one of those. And so now I'll branch it and solve for each. So 3x minus 8 equals 3, and 3x minus 8 equals negative 3. I'll add the 8 over, and then divide by 3. I'll add the 8 over here, and then divide by 3. And we could always check our answers. I highly recommend it, just to make sure you get the right answer. I'll put, let's see, 11 divided by 3. I'll store it in as my x. And so I'm going to have 3x minus 8 squared plus 4. It equals 13, so that one checks. And then I'll do 5 divided by 3, store as my x. I'll come back up, copy and paste it. It equals 13 as well, and so both of them check. This one asks, what would be the parent function? So these bars right here mean absolute value, so that's my parent function, absolute value, or y equals absolute value of x. Graph the system, so I need to solve both of these for y, so I'll come out to the side. 2x minus y is less than or equal to 3, and 5x plus y is greater than 8. So for my first one, I'll subtract 2x over, and I'll divide by the negative 1. That's going to flip my inequality and change all my signs. On this one, we'll subtract 5x over, and that one's done. So for this first one, we're going to go down 3, 1, 2, 3. That's my y-intercept. My slope is 2, so I'll go up 2, right 1, up 2, right 1. And I'll draw that line going through all these points. And this one would be shaded above, so I'll just kind of do a light shading, but it's going to be up above the line. And then this one, we're going to start at 8. It's going to be a dotted line, and we're going to go down 5, 2, 3, 4, 5, and over 1, down 5, over 1, and this one's a dotted line going through these points right here. And this one's greater, so we're going to go above, and so this is where it's commonly shaded. And so every point inside this double shaded region would be a correct solution. Solve for x, the absolute value is already by itself, so we're going to branch it. And so I'm going to have 2x minus 3 is less than 13, but also 2x minus 3, flip the inequality, greater than negative 13. So we'll add 3, 2x is less than 16, divide by 2, x is less than 8. We'll add 3 over here, 2x is greater than negative 10, divide by 2, x is greater than negative 5. Graphing this one, that's going to go left 2 and down 7. That's going to make a vertical stretch of 2. So instead of going over 1 and up 1, we're going to go over 1 up 2. You can also plug this in the calculator just to check. When I go over 2, 2 squared is 4, but then we're multiplied by 2, we're going to go up 8. So there's my graph. And like I said, you can always put this in the calculator and check that you did it correctly. Write the equation that is translated from this parent function to the right 4 units. So x minus 4 will be inside the absolute value, down 9 minus 9. That's it. There are 310 people in attendance at Hairspray this weekend. There are 4 times as many students as there were adults. And write the system of equations. So we only have students and adults, so A plus S is equal to 310. But there are 4 times as many students as adults, so more students. And so like we did earlier, for every 1 adult, we're going to multiply by 4 to get the number of students. And so we need to subtract 1 of them over. I'll do 4A, move the S over, minus S equals 0. And then we're ready to put it in our matrix. This one's a 2 by 3. Oh, 2 by 3. So we have 1, 1, 3, 10. 4, negative 1, 0. Second matrix, we're going to do the double REF. 62 and 248. So 62 adults, 248 students. All right, let's see if this one's major array. My x's are in a line, my y's are in a line, my z's are in a line. Everything's lined up, it's ready to go. And so I'll go back into the matrix. This one is a 3 by 4, 3, 2, negative 1, 11, 2, negative 1, 2, negative 3, 1, 3, negative 1, 8. There's my answers. So 2, 1, negative 3. So on this one right here, we could do it by graphing, substitution, elimination, or we could do matrices. Either way works. I'll go ahead, since they're both in y equals, just go ahead and do it by graphing. And so I'll go into my y equals. I'll have 2x plus 15 and negative 1/3 x plus 1. I can see the intersection, so I can go second trace. 5 is intersect. Enter, enter, enter. Negative 6, 3. All right, for number 22, we'll solve for x. And so I'll go ahead and get y by itself on this bottom one. Y equals x plus 1. And so now that they're both solved for y, we're just going to set these two circles equal to each other. So x squared plus 1 equals x plus 1. Anytime I have an x squared and an x, we want to get everything to one side. And so I'm going to subtract the x over and subtract the 1 over. So I get x squared minus x, those cancel out, and I'm just left with 0. We'll GCF this, we'll plot an x from each, left with x minus 1 equals 0, and then we'll set both of these equal to 0. And so x equals 0, x minus 1 equals 0, and so x equals 0 and x equals 1. Those are my two answers. And then I'm going to come back over here and we'll plug these in just to see what my y value is. So for my first one, if I plug in 0, 0 plus 1 is 1. And for the second one, I'll plug in 1, 1 plus 1 is 2. And so there's my two coordinates, my two solutions. Write the equation of the absolute value function. So we have absolute value of function that has been vertically stretched by a factor of 3, shifted to the right 5 units, and shifted down 2. write the equation of a parabola, so that's x squared, that has a vertex at -2, 5, with an a value of 1, so no vertical stretch or compress. So on this one, we're going to have in parentheses, it's going left 2, so x plus 2 squared, and then plus 5. Over what line do inverses reflect? That's the y equals x line. And so anytime you have inverses, they always reflect over this dotted line y equals x. What is the sum of x and z for the solution? So we need to find the solution and then add my x and z together. And so just make sure everything's lined up. Everything looks good. There's no z up here, so that's going to be a 0. But we'll go into our calculator. Second matrix, this one is a 3 by 4, and so I got 3, 2, 0, 13, because there's no z. 3, 2, 1, 13, 2, 1, 3, 9. Go through all my steps. So 5, -1, 0. So 5, -1, 0. That's my x, my y, and my z. The sum of x and z, so we're going to add 5 and 0 to get 5. Solve for x in the following. So we'll isolate the absolute value first. We'll add the 6 over. That gets 24. We'll divide by 3 to get 8, and then we'll split it. Once you have the absolute value by itself, it's time to split it with the positive and the negative. So 5x plus 4 equals 8, and 5x plus 4 equals -8. Subtract the 4 over, 5x equals 4, x equals 4/5. We'll subtract the 4 over, and divide by 5, and x equals -12 over 5. And then we could always plug it in and check. But those are my two answers right there. What's the transformations of the equation? The negative is going to reflect over the x-axis. The 1/5 will be a vertical compression because it's less than 1 by 1/5. We're going left 2 and up 4. Inverse, we'll switch the x and y. So 4x equals y plus 4, and then we'll solve for y. So we'll just subtract the 4 over. List the domain and range of the equation. So domain and range. There's a quadratic, so my domain is all real numbers. For my range, this one is going to the left 3, down 7, and we're going downward, so that way. So my range has a low of -infinity, and this highest point right here was -7. Solve for x, we'll add the 7 over. Get rid of the squared by taking the square root, and anytime you go square to square root, it always equals a plus or minus. So I'll branch it. 2x minus 3 equals 4, and 2x minus 3 equals -4. Add the 3 over. 2x equals 7, so x equals 7 over 2. Add the 3 over. So 2x equals -1. Divide by 2 to get -1/2. On to the last page. What are the roots of the parabola? Roots are my x-intercepts, as a reminder. We're across the x-axis, and so we'll plug in 0 for y and solve for x. You could solve using quadratic formula, factoring, go to your calculator. I'm going to do factoring. So I've got -10 on top because that's my a times my c, 2 times -5. My b is 3 on bottom. And I'm trying to think what multiplies to -10 and adds to 3. That's going to be 5 and -2. We're dividing by my a of 2. This simplifies to -1 over 1. And so I'm going to have 2x plus 5 and x minus 1. Set it equal to 0. And so we'll solve for each of these. So x equals, I'll subtract 5, -5, and divide by 2. -5/2. We'll add the 1 and +1. Standard form, that means I just need to multiply these together. I need to FOIL it. And to multiply the x by both sides, the -5 by both items. And so y is going to equal x squared plus x minus 5x minus 5. And then we'll combine like terms to get x squared. That's going to be -4x minus 5. The last one, graph the equation. You could use a calculator on this one. I'll find the vertex. So my x is negative b over 2a. So negative 8 over 2 times negative 1. So that's negative 2, which means that's 4. That was negative 8 divided by negative 2, which gets 4. And then we'll plug in the 4 to get my y value. And so it's going to be 16. Then we have the negative on the outside. So negative 16 plus 32 minus 14. And so we can just go in the calculator from here. Negative 16 plus 32 minus 14 gets me 2. 1, 2, 3, 4, 1, 2. We got a negative in front, which means it's going to go down, no stretch or compress. So over 1, down 1, over 2, down 4. And again, you can go into your calculator to get these points. There's my parabola right there. And that finishes our review. Let me know if you have any questions. Make sure you're ready for next week.